Chapter 1, Vocabulary Day 3. Okay, so back on that first page, the data levels of measurement. There are 4 types of data. There's nominal, ordinal, interval, and ratio. A nominal is qualitative only, categorized. Think of this as like labels, names, qualities, things like sex, the ticket number, ticket symbols on for the stock market. It could be what country you're from, that kind of thing. And then the next one is ordinal. These could be qualitative or quantitative and can be arranged in order or ranked, but the difference between the entries are not meaningful. So an example is the TV Guide list of top shows. Number 1, Wayward Pines. Number 2, Bachelorette. The data sets that has values listed in order from 1 to 3. It has numbers, but they don't really mean anything mathematically. It's literally just a listing number. Interval can be ordered and meaningful differences can be calculated. A 0 entry represents a position on a scale. Think of this like a number line, like years being put in a numeric order. So 2000, 2001, 2002. Those are numbers that can be used in some kind of mathematical equation. And then ratio is similar to the interval level. The data values can be formed so that one data value can be meaningful expressed as a multiple of another. So the example is that you have the home run totals, 244 for New York, 224 for Texas, 212 for Boston. You can compare the numerical data as ratios of one team to the other. So there's a ratio of 224 to 244 of Texas to New York. Nominal is qualitative only, categorized, and no math. Ordinal is qualitative or quantitative, but again, no math. Interval is ordered and meaningful. The differences can be calculated, and 0 means that there's a position on the scale. So think of a number line. And then ratio is similar to interval. The data values can be found. Ratio is similar to interval. The data values can be found. You can find out a multiple of each other. So ratio is used in actually figuring out a number, some kind of an equation that you can use for predictions. So we did that. You may have done that in your Algebra 2 or Math Models class where we were predicting what the y value would be if you put in an x. But to be able to do that, you first had to find the ratio between all of your data. So guidelines for designing a statistical study. You want to first identify the variables of interest, the focus, and the population of the study. The variables are the things you're looking for. They could be numerical, they could be qualitative, but they have to be something that you're actually looking for, a result that you're looking for. Number 2 is develop a detailed plan for collecting the data. If you use a sample, make sure the sample is representative of the population. If your population you're trying to represent is 10 million, 100 is not going to cut it. So you need to make sure to get something big enough. So you might do 100,000 or maybe 500,000 or something like that. But depending on how large your population is, depends on how large you really want your sample. Number 3 is collect the data. Number 4 is describe the data using descriptive statistic techniques. And those are the things that we're going to be doing in this class. So that we'll get into more detail later. Number 5 is interpret the data and make decisions about the population using inferential statistics. So once you've got your data, you crunch the numbers per se, and then you compare that information to what you're expecting, and then decide, okay, did it reflect what you were expecting, or did it reflect something completely different? And then number 6 is identify any possible errors. Did you have any data that was outliers, that were numbers that did not belong? So for example, you had you asked people's height and people were telling you 5 foot, 4 foot, 3 foot, and then you had somebody that answered 100 foot. Obviously, no person is 100 foot tall, so that is called an outlier, and that would cause you to have errors. So you would want to chunk that one out so that you could get a better explanation of what was going on. Okay, so there are 4 different ways that you can do examples or gather data. You could use a simulation, you could use a survey, you could perform an experiment, or you could do an observational study. So using a simulation, you use a mathematical or physical model to represent the conditions of the situation or process. The military uses games almost to actually simulate battles so they can get an idea of potential casualties in a situation. So that's one example. Or you might, the example they give you is automobile companies do crash test dummies to see how the reaction to the bodies of the victims in automobile accidents might be. A survey is an investigation of one or more characteristics of the population, usually by asking questions. Questions should be worded carefully so that the biased results are not recorded. This happens quite often, that the questions are worded in a way to make a specific answer come up. You have to be very careful when you're doing that. So, example of a survey that you might do is you might send a survey out to all of the seniors to find out what they want the theme for prom to be, and you might give several possible choices as a bullet multiple choice type thing, or you might have a free response where they could type in, and then you would kind of sort that to see what was the most often theme. You can perform an experiment. It's a treatment. A treatment is applied to a part of the population and responses are observed. Another part of the population may be used as a control group in which no treatment is applied. In some cases, these are subjects given a placebo made to look like the real treatment. The results of the groups are then compared and studied. This is used in medicine a lot. You might have seen TV shows that showed that kind of thing going on, where a specific terminal type patient might be given a specific new potential drug, and then they actually study it. They do these in things called double blinds, so that neither the person that is receiving the medication or placebo, nor the person giving the giving the medicine can tell you which one's which. The packages are made to look alike. The only way it's told, the only ones that will actually know for sure is at the very end, the barcodes give it away. Okay, so the last one is an observational study. This is where a researcher observes and measures characteristics of interest of a part of the population, but does not change the existing conditions. That part is very important. An observation will not change the conditions. They're not introducing a new factor, a new variable into the environment and then seeing how it works. They're just simply watching what's going on already. So an example is you might, if the seeing how much noise of a particular vehicle that's already being driven in that area is causing reaction by the local wildlife. That is an example in an observational study. Okay. So the next page. So on this page, you're basically reading through a couple of examples and deciding if it's a survey, an experiment, a simulation, or an observational study. And you can see the answers that I've given there. Okay, the last one. No, sorry. Okay, the next page is the confounding variables and the placebo effect. So confounding variables occurs when an experiment cannot tell the difference between the effects of the different factors on a variable. So a restaurant completes a full remodel, major street construction shuts down, road leading to the restaurant, few customers. There's few customers, but you can't tell why. So there's another factor that is not something that is there's a factor, an outside factor that's affecting the results, that may not be recognized when you're trying to do it. So the restaurant may be thinking, well, my remodel didn't do a good job, but it's really not the remodel causing the problem. It may be the construction outside. But since the construction outside was not actually part of the variables that they were observing, they wouldn't have recognized that as being the problem. The placebo effect is when a subject reacts favorably to a placebo when in fact the subject has been given no medical treatment. This actually does occur a lot in medicine. There's a reason why people believe in mind over matter, because the placebo effect has a tendency of sticking its ugly head up. A migraine patient receives the placebo instead of the drug, but still reports less migraines. His mind is telling him he's getting a medicine, even though he's not, and it is making him feel better. These type of effects generally do not last very long. Okay, so this one is talking about blinding. This is kind of what I was talking about a minute ago. It's a technique where the subjects do not know whether they are receiving the treatment or the placebo. A double blind is where neither the experimenter nor the subjects know if the subjects are receiving a treatment or placebo. The experimenter is informed after all the data has been collected. And then the randomization is the next one. Randomization is a process of randomly assigning subjects to different treatment groups. Random block design is dividing the subjects with similar characteristics into blocks and then within each block randomly assigning treatment groups. So an example is, let's put people, separate them by age groups or by gender groups. And then within those groups, now we're going to separate them into whether or not they're getting the treatment or they're getting the placebo. And then matched pairs design is subjects are paired up according to similarity. One subject in the pair is randomly selected to receive the treatment and the other treatment or maybe the placebo. Two subjects can be matched based on age and then assigned two different treatments.